This is 2.7 part 4, and we have a word problem here that's slightly more complicated than the previous ones. There's not always going to be one straightforward method to doing all these word problems. However, if you read the questions carefully, redraw the triangles separated, and just take it step by step, it is going to lead you in the right direction. Don't panic if when you first read the question you don't exactly know what to do. Just start by doing something. So in this case here, it says the angle of elevation of the top of a tree is 27 degrees. So basically imagine you standing on the ground, and what it says is the angle of elevation to a tree, there's a tree, is 27 degrees. From the same point on the ground, the angle of elevation of a hawk flying directly above the tree is 43 degrees. So what we have is a bird up here, and this entire angle is 43 degrees. Well, we did know as well that the tree is 12.7 meters tall. The question is, how high is the hawk above the ground? So we have two triangles here. And what I'm going to begin by doing is I'm going to begin by looking at the bottom triangle, just the tree question. So the bottom triangle has a right triangle that looks like this, where this is 27 degrees, this is 12.7, and I want to be able to find another side in this triangle that's going to be helpful for the large triangle. And if I look at the large triangle over here, it has these three sides. The only other side that's going to be helpful in this big triangle is the bottom side, because both triangles share the bottom side. So I'm going to find side X. So let's take a look at our variable list. Obviously this is the hypotenuse, this is the opposite, this is the adjacent. Let's make a list of our numbers. We have a 12.7, we have a 27, and we have a question mark, which is our X. 12.7 is opposite, and our 27 is our degrees. Now, which formula is this? We're looking at tan. Tan of A is equal to opposite over adjacent. Tan of 27 is equal to 12.7 over X. The tan of 27 is 0.5095 is equal to 12.7 over X. Put this over 1 and cross multiply. 0.5095x is equal to 12.7. Let's get the x by itself by dividing both sides by 0.5095. And we are going to get x is equal to 24.9. Again, we're asked to do to the nearest tenth of a meter. Now what that tells me is at the bottom of this triangle right here is 24.9. Now what I want to do is I want to go back and I want to redraw the large triangle. And the large triangle has an angle of 43 at the bottom. It has 24.9 here. Now this 12.7 that you see there is certainly part of it, but because it's not the entire length of the side, I'm just going to refer to this entire side as the variable y. Let's label our sides. This is the hypotenuse, this is the adjacent, this is the opposite. Making up our variable list, we have a 43, we have a 24.9, and we have a y. The 43 is the angle, the 24.9 is the adjacent, and the y is the opposite. We're again going to use tangent for this question. The tan of A is equal to the opposite over the adjacent. The tan of 43 is equal to y over 24.9. The tan of 43 is 0.9325 is equal to y over 24.9. Putting this over 1, we're going to cross multiply, and we're going to get y is equal to 24.9 times 0.9325, and y is going to be equal to 23.2. The question asks, how high is the hawk above the ground? Well, going back to my original diagram, if I find the entire side of this large triangle, I have discovered how high the hawk is above the ground. And that is in fact what I've done right here. So the hawk is 23.2 meters above the ground.